the first thing that you have to do is open up your code, which is going to be, if you look at the FluoroMatch IM version 1.2 or whatever your version is, the latest one. And then there'll only be one code in this, but this is version 2 of the code. So you double click that, open it up, or better yet, open it in a text editor, press Control A, C, and make sure that you run it through the R GUI, which can be found in this directory. So R 4.4.0 bin x64 and then R GUI. So you would double click and run it in there to make sure that it has all the packages pre-installed. If you connect the RStudio to those same packages that are distributed that will be in the library, that works as well. But either way, you'll run it. And I'm going to run it. You just do Control A, run all. In this case, I'm just going to run a subsection for testing. We would run it all. And then you'll get a pop-up that you then want to go to. So that pop-up should show up. There it is. If you don't see it, then you can go over to your toolbar and you should be able to see it as this little feather icon. Because sometimes it appears behind things. So now you want to choose your input file. So your input file is going to be whatever CSV table has your drift times, your CCS, things of that nature. I'll look a little bit into the formatting of that. And so you want to click your feature table that's already been 4D picked. So it has your iMobility information, drift time, your retention time, your peak areas, your mass to charges, all of that already done. So you can use open source software for that or vendor software for your peak picking. Note that when I selected that file, it should be in the same folder as your MZML file, and this file has to have target _neg in the name somewhere. _neg has to be at the end, and this .mzml file is the one that contains all your full scan data. So they need to be in the same folder. It automatically grabs that based on the name. Now you want to choose your library, which comes with the software again. So if you go to your software, and then you go to scripts and libs, there should be your library. Note that both your library and repeating units, including if you make a new one for the library that has all your CCS values, should be in this folder, scripts and libs, because it also grabs the scripts folder from this directory, knowing where your library is. So always have the libraries in this folder, as well as the repeating units, even more importantly, in this folder. So press OK. So it's OK for the repeating units file. And then we need to make sure we have the right columns for your input table. So your input table can have columns in different orders, and we need to make sure that those are correct. So in order to do that, we're going to go into our table, and we want to make sure, so the mass column says 5 here, but if we look, it's actually in column 1, 2, 3, 4, 5, 6, 7, 8 in Excel, or in Office Libre, which is like a free version of Excel. You should see it at the bottom, this 8 columns. And so we would put 8 for the mass. It's very important that these are right, otherwise it will error. 2 for the retention time. The CCS is in 6. Column 6. Oops. Definitely don't want to mess anything up. 1, 2, 3, 4, 5, 6. And then the drift time column is in 4. And the row ID column is 1. We recommend that you always keep the row ID as 1. And if you don't have an identifier, it should just be unique numbers. You can just in Excel or Freestyle, put 1, 2, and then drag down, and it will fill in all of your numbers for you in a new column. So that's something. And then that's all except for the row starts, which is 2. And you should always have row start as 2. There could be some errors. So if you have more than one header, maybe remove those headers and you can paste it in after it's been processed. But just have a single header. So that's it for that. I'm not going to save in case you made any accidental errors. And then the other thing is you want to look at your software libraries in case you add your own libraries and make sure that all the columns are correct here as well. So if we look at their library and we open this up, the default library will always be correct, so you won't have to change this. So the name is 1, the formula is in column 2. We don't need an identifier, so that's 0 right now. And then the smiles column, which is going to draw out the structures, happens to be in column 23, as you can see from down here. So again, you don't have to edit these unless you're creating your own library. And if you are creating your own, definitely contact us. We're very interested. So we'll close that. And then we'd always go yes for retention time order flagging and drift time order flagging. In that case, it considers something a series in the homologous series no matter what, even if it's in the wrong retention time order. But it will only count unique members of a series if they're in the right order. So let's say later on in your visualizer, you want to filter to those that have only 8 members in the series, or 7 or 6. You're looking for unknown, which have a lot of members in the series. They won't count as a member in the series if they don't have the right retention time or drift time order. Also, only each unique mass counts as 1 in a series. So even if you have 5 isomers for 498.9, let's say, they would still only count as 1 in the series. And then as far as the mass window is concerned, for mass accuracy matching, obviously this is something you might want to edit. So this would be a plus or minus 0.005 Daltons for accurate mass matching. And also plus or minus 5 ppm for accurate mass matching. And then the CCS window, we use 2%, although for like Agilent 6560s and some of the more accurate instrumentation, you can lower this. Or if you have more error, you can raise it. So usually we keep these similar. Same thing for mass accuracy. You might want to raise it if you have some mass accuracy window that's a little wider. This is the mass defect that captures most PFAS based on the EPA master list. So, and again, this is just a flag, so it's not going to remove anything from your data set. So not extremely important, but definitely of interest. And then you want to put your polarity, which right now we only have negative mode CCS values, so keep it negative. I usually like at this point to take a screenshot of the settings. That way if you run into an error, you want to run this again, you have the same table format, you don't have to look back at the files to get the, and then all you do is click run. And that is it. And then we'll have a separate video as far as how to troubleshoot any issues, as well as how to interpret the results, go through the visualization,